What is standard normal distribution? The standard normal distribution, also called Z distribution, is a special normal distribution where the mean equal to 0 and the standard deviation is 1. This session we will cover standard normal distribution, standard score or Z score. Use the standard normal distribution to find probability, hypothesis testing, p-value and Z test. Come to standard normal distribution, also called Z distribution, special normal distribution where the mean equal to 0 and standard deviation is 1. Mean equal to 0 and standard deviation equal to 1. Any normal distribution can be standardized by converting its value into Z score. Z score tell you how many standard deviation from the mean each value lies. The random variable of a standard normal distribution is known as standard score or a Z score. It is possible to transform every normal random variable x into a Z score using the following formula: Z equal to x minus mu by sigma, where x is normal random variable, mu is the mean of x and sigma is the standard deviation of x. Then how to calculate a Z score? To standardize a value from a normal distribution, convert the individual value into Z score. Subtract the mean from your individual value, divide the difference by the standard deviation. Here x equal to individual value and mu mean and sigma, that is standard deviation. Example: finding a Z score, you collect set score from student in a new test preparation course. The data follows a normal distribution with mean score m of 1150 and standard deviation SD, that is 150. You want to find the probability that set score in your sample exceed 1380. To standardize your data, you first find the Z score of 1380. The Z score tells you how many standard deviation away 1380 is from the mean. Step 1. Subtract the mean from the x value. Here our x value equal to 1380. M mean score equal to 1150. You can see this is our mean score. X minus m equal to 1380 minus 1150, that is 230. Step 2. So divide the difference by the standard deviation. Our standard deviation SD equal to 150. So Z equal to 230 by 150, that is 1.53. The Z score for a value of 1380 is 1.53. The Z score for a value of 1380 is 1.53. When Z score of 1380 equal to 1.53. That means 1.53 standard deviation from the mean of your distribution. If our distribution mean here, then 1.53 from our mu. So we can find the probability of this score using Z table. Use the standard normal distribution to find the probability. The standard normal distribution is a probability distribution. So the area under the curve between 2 points tells you the probability of the variable taking on a range of values. The total area from here to here, total area under the curve is 1 or 100%. Every Z score has an associated p value that tells you the probability of all values below or above the Z score occurring. This is the area under the curve left or right of the Z score. Here, hypothesis testing. The assumption made for a statistical test is called null hypothesis. Previous video we discussed, that is H0. Alternative hypothesis H1 contradicts the null hypothesis, stating that the assumption don't hold the true at some level of significance. Hypothesis testing lets you decide to either reject or retain a null hypothesis, like H0 mean null hypothesis. The average BMI of boys and girls in a class is the same. Alternative hypothesis H1, the average BMI of boys and girls in a class is not the same. To compare the p-value to a threshold value called the significance level, it often sets the level of significance of to 5% or 0.05. If the p-value greater than 0.05, accept the null hypothesis. If the p-value less than 0.05, reject the null hypothesis. Actually, to determine whether a finding is statistically significant, you need to interpret the p-value. It is common to compare the p-value to the threshold value called the significance level. What is p-value? The p-value is a number calculated from a statistical test. Describes how likely you are to have found a particular set of observations if the null hypothesis were true. P-value are used in hypothesis testing to help decide whether to reject the null hypothesis. The smaller the p-value, the more likely you are to reject the null hypothesis. Popular hypothesis tests are chi-square test, t-test, z-test, analysis of variance, ANOVA. Z-test is a very important topic. Let's work through an invented research example to better understand how the standard normal distribution works. Also, you can understand hypothesis test. As a sleep researcher, you are curious about how sleep habit changed during COVID-19 lockdown. You collect sleep duration data from a sample during a full lockdown. Before the lockdown, the population mean was 6.5 hours of sleep. The lockdown sample mean is 7.62. To assess whether your sample mean significantly differ from the pre-lockdown population mean, you perform a z-test. First, you have to calculate a z-score for the sample mean value. Then, you have to find the p-value for our z-score using z-table. Step 1. Calculate z-score. To compare sleep during and before the lockdown, you convert your lockdown sample mean into a z-score using the pre-lockdown population mean and standard deviation. You know the formula z equal to x minus mu by standard deviation. Here x is the sample mean, mu is the population mean, x that is sample mean, mu population mean, sigma that is population standard deviation. So you can say x value is 7.6 and mu value 6.5, standard deviation 0.5. So x equal to 7.62, mu equal to 6.5 and standard deviation 0.5. So z-score equal to 7.62 minus 6.5 by 0.5, that is 2.24. A z-score of 2.24 means that your sample means is 2.24 standard deviation greater than the population mean. Step 2, finding the p-value. To find the probability of your sample mean z-score of 2.24 or less occurring, we use the Z table to find the value at the intersection of the row 2.2 and column 0.04. Here we use the portion of the cumulative table. This table tells you the total area under the curve up to a given z-score. The first column of a Z table contains the z-score up to the first decimal place, and the top row of the tables give the second decimal place. To find the corresponding area under the curve for a z-score, go down to the row with the first two digits of your z-score, go across the column with the same third digit as your z-score. Here z-score is 2.24, mean that is positive value. The first column of Z table contains the z-score up to the first decimal point, mean 2.2, and top row of the table gives the second decimal point that is 0.04. So you can see this one over up to first decimal point and second decimal point this one. So intersection of this and this intersection, that is the value 0.98745. Positive z-score table. To find the value on the right of the mean, here is the z, as we can see in the graph alongside. Corresponding values which are greater than the mean are marked with a positive score in the Z table and represent the area under the bell curve to the left of Z. We can see also negative z-score table. Negative z-score table to find the values on the left of the mean, as can be seen in the graph alongside. Corresponding values which are less than the mean are marked with a negative score in a Z table and represent the area under the bell curve to the left of J. But our z-score value is 2.24. So we have referred positive z-score table. The table tells us that the area under the curve up to or below our z-score is 0.9874. You can also cross check 0.98745. So that is 0.9874 and 5. This means that your sample's mean sleep duration is higher than about 98.74% of the population's mean sleep duration pre-lockdown. Since the total area of the curve is 1, we subtract the area under the curve below our z-score from 1. A p-value of less than 0.05 or 5% mean that the sample significantly differ from the population. Here, probability of Z greater than 2.24, 1 minus 0.9874, that is 0.0126. 0.0126 is less than 0.05. With a p-value or less than 0.05, we can conclude that average sleep duration in the COVID-19 lockdown was significantly higher than the pre-lockdown average. I think now we can understand Z test, also hypothesis test, and you can find the z-score value, use z-score positive table or z-score negative table.